Now we're going to talk about economics, but we're going to talk about economics specific to the computing industry, particularly how the economics of the computing industry are probably not the economics that you might have learned earlier in school. I like to subtitle this lecture, Why Did My Econ 101 Professor Lie to Me? Mainly because what you learned in your college economics course is not what you're going to learn here. In fact, I'm going to start off by talking about some of those, some of the laws and things that you learned in your Econ 101 class, just as a way to compare them to some of the completely upside-down phenomena that we're seeing in the computing industry that are made possible by a number of interesting characteristics of computing. Think about the impact of things like zero shelf space, the fact that I can have products that need no storage, or at least storage in such a small quantity that it doesn't mean anything. Things that have infinite shelf space. All those sorts of things play into the economics of the computing industry and make them quite different. Now, this chart is interesting. It's about transportation. And notice on the vertical here, you've got percentage of light speed as a measure, and you've got time in years across the bottom. Now, notice if you start on the left, you've got horse transportation, which lasts a really long time, but it doesn't really get better over time. It is what it is. And then it gets displaced by trains that, notice, it actually starts worse than the horse, but then gets better, but not a whole lot better. This is actually a phenomenon we'll talk about later on when we get into disruptive technology theory. But that's what happens there. And then a little bit further is the invention of the automobile, which again starts worse than trains, but then gets better than trains. And then the aircraft does the exact same thing. Now, what you really want to pay attention to is the dotted line here. Look at the envelope. What does it tell you? It tells you that there's a very rapidly increasing pace. We were slowly increasing our ability to transport ourselves and goods over a large number of years. And only in the past 100 years has it just exploded to the point that we're getting faster and faster all the time. Now, if this is true in the transportation industry, what do you think is happening in the information technology industry? Well, let's take a look. So first we're going to start with some classic laws of economics. Now, these are the ones, if you crack open your old economics book, you'll find these. You'll find things like the law of one price. What does that say? In an efficient market, all identical goods must have only one price. So if you go to your grocery store and you look at a loaf of bread, the loaf of bread sitting right next to it is probably not a whole lot different in price. And I'm not talking about like whether it's gourmet or something like that, but in general, they're about the same. And the law of diminishing returns, another classic law of economics that says adding more of one factor of production while holding all others constant will at some point yield lower per unit returns. What does that mean? It means when everybody's starving, I can charge pretty much anything I want for my loaf of bread. But as I keep producing bread, eventually people aren't hungry anymore. And the return I get on my loaf of bread gets smaller and smaller and smaller, eventually to the point of becoming zero. The law of supply actually goes along with the law of diminishing returns, which says that an increase in price results in an increase in quantity supplied. So the more something is worth, the more industry is going to supply it. So we're going to start with a law that everybody thinks they know well, which is Moore's Law, developed by Gordon Moore, former CEO and co-founder of Intel Corporation. But it might not be exactly what you thought it was, but you're close. He claimed in the 60s that the number of transistors per chip will double about every 18 months. Now, you probably thought it was that the speed of the CPU was going to double every 18 months. Of course, the fact that the speed of the CPU and the number of transistors are related to each other means that you're still right, but that isn't exactly what he said. So here's what it looks like in action. Look at this chart. The green line is the number of transistors, and you'll notice that this is on a log scale, so the fact that it's almost a straight line means that it is in fact exponential. The dark blue line is the clock speed, and you'll notice that that's topping off lately. And the light blue is power, and the purple is performance per clock speed. So interesting that his law has continued to hold, but the fact that there's actually a little curve in the dark blue line tells you this is the reason why you're seeing dual-core and quad-core CPUs now, is simply because we're not able to squeeze all that speed out. We're actually meeting physical limits of the materials. So we can talk about learning curves specifically for hardware in the computing industry. So we already talked about processors, about 50% per year. Networks actually are even a little bit better, 70% per year, starting to slow down as well. Disk capacity is an interesting one because we've almost gotten to the point now where we almost don't count disk capacity as having a cost. It's gotten so cheap, but that wasn't always true. Now notice what I said on the bottom there. There's Moore's second and lesser known law is that the cost of building the next generation fabrication facility also doubles. Now, think about this. In the early days of Intel, the cost of building a fabrication facility was so high that Intel was almost betting the company every time they put out a chip. Because if the chip didn't sell, the company was going to go under. Now, that's not true anymore. But it certainly was in the early days. So think about what bravery it took to actually bet the company every time you modify your chipset. That's what Intel was doing. That's why they're so successful. Now, this is an interesting one. Bill Davidow was a former VP of Marketing and Sales at Intel Corporation, and this is what he said. Obsolesce your product before your competitors do. Now, think about what he's saying there. Normally, you put a product out and you want to squeeze every ounce of life out of it that you possibly can. I mean, you put your resources into it, and as long as a customer is willing to buy it, you want to get as much out of it as you possibly can. Bill Davidow thought about this a little bit differently, and what he did was he used price to control market share, his own market share, from one product to the next. So when the PowerPC was threatening the conversion from Pentium Pro to Pentium, from Pentium, what Bill Davidow did was use price to get his own customers to move from the Pentium to the Pentium Pro. Let's look at how he did that. If you look at this chart, the red line is the price for the Pentium Pro. Notice when it first was introduced in 1995, it was high. What he did was he dropped the price of the Pentium Pro, that's the new stuff, while not dropping the price of the Pentium, the old stuff. Notice what happens. The green line, the units of Pentium Pro, goes up. The blue line, units of Pentium, go down. Think about this. At that period of time, if for some reason you wanted to buy a Pentium chip when the Pentium Pro was available, he forced you to pay a premium for the old technology because he didn't want to sell you the old technology. He would have rather jumped the whole thing and moved everybody over to Pentium Pro. He just couldn't do that. So what he did was he came up with this scheme by using price to get everybody converted. Again, the idea is obsolesce your own product. Get everybody off the old stuff onto the new stuff so that you can invent new stuff again and get them to move a second time. Now here's a big one for those of us in the Department of Defense, is lock-in. Since we don't really make our own products too much, we're always have to be careful of this. So the idea here is you want to encourage customers to become, quote-unquote, addicted to your product. You want them locked in. You don't want them moving off to another product. When you buy a loaf of bread, there's no lock-in mechanism to keep you from buying someone else's loaf of bread the next time. When you buy Microsoft Office, there's lots of reasons why you don't buy somebody else's Office product the next time. So look at this quote here. I know it's a little bit dated. It's from 97, but listen to this quote by Steve Ballmer, who was then president of Microsoft. He's now the CEO, but he was president then. He said, if you're going to get pirated, you want them to pirate your stuff, not the competitor's stuff. In developing countries, it is important to have a high share of the piracy software. That's interesting. He's not making any money off of pirated software, yet he still wants to control the pirated market. He wants people stealing his stuff, not somebody else's stuff. Why? Well, if you're some kid in college and you've got an illegal copy of Microsoft Office, when you go and take your first job and they say, what software do you want? What are you going to say? Microsoft Office, because it's what you know. So he's actually getting future customers off the piracy market. So some mechanisms for lock-in, and these are the things that we ought to be paying attention to because we want to avoid lock-in where we can. You can't always avoid it entirely, but you at least want to be aware of it. So one thing would be file formats. I can't switch to your product because it won't read my old files. How about corporate policy? Things like NMCI that force something on you because it's the corporate policy. Usability. Well, all things are equal, but I don't want to switch because it took me so much time to learn this product, I don't want to have to learn another one. What about compatibility? I can't switch to your product because it won't work with my other applications. This could be beyond file formats. It could be that it doesn't plug together with my other pieces. How about sunk costs? I can't switch because I already paid for this product I'm using now. These are all reasons why people don't switch. There's probably others, right? But these are things that we should be thinking about inside of the Department of Defense because we want to try to avoid them where we can. Now, this one I call the Borg Law. It's got an asterisk because I made this up, but what you will, if you look up Borg Law, you won't find anything. But if you look up absorb and extend, you will. And what this means is when you fall behind, copy the market leader, add proprietary features, and lock your customer in. Lots of examples of this. Microsoft is actually the master of this. So they fell behind in spreadsheets. Lotus 123 was way ahead of them. So in the very, very early versions of Excel, they tried to copy Lotus 123, and then they extended it. And then people who were using Excel because they got it with their Office product, they weren't going to go back to Lotus 123 because they were used to Excel now. Same thing with Java and C#, which is a programming language, Oracle Database and SQL Server, SOAP and BizTalk. SOAP is called Simple Object Access Protocol. It's a way to execute code on distributed machines for distributed computing. There's lots of examples of this where you take a product, you copy it, really common in the open source field too, where you copy, you get caught up by using open source, then you extend. You put your own proprietary feature on it that locks people in. Oracle's extensions are a great example. If you think you're SQL compliant because you're using Oracle's products, but you're using their extensions, don't try and switch to another product because your stuff won't work. The extensions will lock you in. Now, how this plays out in the marketplace is like this. I know this is an eye chart, but what it's showing you is around this circle on the top are technology companies, companies that produce technologies. On the bottom are interests, different interest groups, right? Then on the right, you've got access, that is access to media. And on the right are channels, are media channels. And what happens is around the rings are these ecosystems form. So nobody does everything. Lots of companies try, but they don't do everything. A media company doesn't produce the TV display that you watch the media on. They partner with them, or they rely on them in some way. They might not even have a formal partnership. But this is where you see companies aligning with each other. So what you get is horizontal market integration, and very important are value chains, because everybody along the way has to provide some value or they don't play a role in this. If you're trying to optimize this for the customer, everybody has to add some value. And the key here is that value chains, as a chain, provide value to the customer, but in and of themselves, no one company does it. Now, coevolution in these ecosystems is interesting because you see different pieces that evolve over time in relation to each other. So in nature, coevolution is, good example is the bee and the flower. They depend on each other. The bee needs the pollen, the flower needs the bee. So they've evolved together to where they rely on each other for their existence. Now, how does this work out in business? Well, the best example you know of is the Wintel industry here, where you've got Microsoft and Intel that relied on each other. Now, how did this work? You bought your new PC, it was great, you loved it, and it served your purposes. And you installed software onto it, and you had it over some period of time. Eventually, it gets slow. You decide you want to upgrade. Well, you upgrade, you're also going to upgrade your operating system. So both Intel and Microsoft benefited every time you revved your software or your hardware, you revved the other one. So they were tied to each other. Okay, now we're getting to the really interesting stuff as it relates to our industry. Now there's this, remember we referred to something called decreasing returns. Remember that? It said that the more of a product you put into a market, the less your return actually is. Well, Brian Arthur of the Santa Fe Institute came up with this idea called increasing returns. And I've made this paper available to you called The Theory That Made Microsoft. Increasing returns says exactly the opposite. It says that the more of your product that's in the market, the easier it is to get your next customer. Let's look at how that works. Well, what the law actually says is that this is the effect that one user of a good or service has on the value of that product to other people. When network effect is present, the value of a product or service is dependent on the number of others using it. We're actually going to see something like this when we look at adoption curves in a future module. But the idea here is Microsoft Office is a great product, and if I was the only one who owned it, it would have value to me. I could produce documents, I could print things, I could build little databases, I could do things with it. It would have value to me. How much more valuable is it when my friends start using it, when my coworkers start using it? We can start sending files back and forth. All of a sudden, the value of getting the first customer in an office gets hard to get the first guy to convert. It gets easier to get the second guy to convert. By the time you've got a whole floor in your office converted, you've got everybody converted because everybody's going to go buy that product. That's what the law of increasing returns says. And so the way this looks graphically is you see the top bar that tops off is called decreasing returns. So there, the more of input X, the less of output Y. Increasing returns goes the other way. It means that the more of input X, the easier output Y, the more you get. Now, Metcalfe's law is also called the network effect, and this was a very important law that was followed by Sun Microsystems, which has since been acquired by Oracle. But it says that the value of the network is proportional to the square of the number of users. So here's a really good example. How useful is a telephone? If you're the only person who owns a telephone, what good is it? It has no value whatsoever. Now, how useful is it if some people have one? Well, it's useful, but it's not super useful. Now, how useful is it if everybody has one? So the value is proportional to how many people actually have this product. So you look at all these companies. All of these companies have to live by these rules. They're all in the computing industry. All of them have to live by them. Now, it's interesting that the ones that are the most influenced by them are the software companies. The hardware companies, a little less so. So Apple, Dell, Seagate, Cisco are a little less affected by these things than the software companies are. But software companies in the computing industry live by these rules. Now, are there any M&S companies that leverage increasing returns? Can we think of any? Well, we don't think in terms of this very often, but it's something, we live in this ecosystem. We use Dell computers, we use Apple computers, we use Cisco routers, we use products from Microsoft. So the companies that we rely on every day are living by these rules. We need to get comfortable with them and figure out how they apply to us. And lastly, we want to talk about how increasing returns can lead to a monopoly. So this is actually what happens here. So you first start out with an innovation. And here we're going to use Microsoft as our example, but and keep in mind, what you think of as the computing industry today was an innovation of Microsoft. That is what became Microsoft. The idea of having an operating system and decoupling software from the hardware on the PC platform, this is what built Microsoft. That is innovation. Now what happens? Bill Gates worked very hard in the early days, going to the extent of cutting deals with hardware providers that were not necessarily economically attractive to Microsoft, but he didn't care at that time. He was trying to build a lock-in. If you read the history of the beginning of Microsoft, you'll see that he was cutting deals that were loss leaders for Microsoft. He was clearly giving products away just to get market share. Then what happens? You get increasing returns. Everybody gets hooked on your product. By the time Windows 3.1 came out, everybody was hooked on his product. Everybody was stuck on it and they couldn't get off. Then what happens? Monopoly. Now, of course, in the extreme case, what happens is what happened to Microsoft. You have a Department of Justice antitrust case against Microsoft that says that they were leveraging a monopoly in one field, in one product line, operating systems, to gain a monopoly in a second one, which was web browsers, Microsoft Explorer. That's what the Department of Justice case was all about. Look at this quote by Scott McNealy, who was then the CEO of Sun Microsystems. PC makers won't even talk to us. They're scared to death of Microsoft. What was he meaning by that? What he meant is that at that time, Sun Microsystems could not get Solaris, which was their operating system, distributed on PC hardware because PC vendors knew where their bread was buttered with Microsoft, and they weren't going to go back on them. So they always signed on with Microsoft and refused to ship their products with Solaris. This is what caught the attention of the Department of Justice. So those are just a few simple rules that are really not very intuitive, and you have to explain what it is about the computing industry, what makes it different. And there are a number of things that we've talked about in this module that just don't exist in other sorts of markets, but they do exist in our field because we are a very IT-intensive field. So we want to make sure that you're aware of all these things, and we live in this ecosystem. So now we're going to learn some new things about disruptive technologies and some other things that are unique to this field.